All right. They saved the best for last. Hello, everyone. I'm Jacqueline Wallace from the illustrious Tuskegee University. And today I'll be talking about assessing physicochemical and microbiological water quality across treated and untreated locations at Tuskegee, the town. So first things first, why is water quality important? Well, we just need to keep the water clean. We need to drink water to live and to survive. The animals that we eat need to drink water to live and to survive. And if we have contaminants in the water that we drink, and the water that we wash our hands in, and the water that the animals drink, then all those contaminants can go into our body systems and cause cancer. They can cause severe problems like we see in Flint, Michigan with the lead problem. And so here are the different sources of pollutions and where they can come from. So towns, cars, driving, kicking stuff in the road. You have basic waste where people just throw litter outside and it gets into the water. You have farm runoff. All this goes into the water and it messes with the water ecosystem, which then messes with everything else. And so the objective of this study is to evaluate and compare the physical, chemical, and microbial communities of numerous sites in Tuskegee, Alabama, 6 treated, 8 untreated locations. This was just to assess the potential harm to people that these water bodies could have. And so my hypothesis was that the treated water sources would have a lower chemical and microbial contamination only because they go through a severe filtration system. However, with the untreated water bodies, it may display greater variation between the two and may have had environmental exposures, but they would not have severe contamination. And so here's my methods and materials. As you can see, this is an indoor water system, regular old faucet. We tested 3 locations on campus, 3 locations off campus into the town. Some of them connected to well systems. Some of them have their own filtration systems. So we tried to get a good variety. We have the Equine Pond, which is located right next to the farmland. So a lot of that runoff from the farmland actually goes into the Equine Pond that the farm animals do drink from. And you have the recreational lake where people like to fish, swim, kayak, all the fun recreational activities. And so here's some context of the buildings that I took samples from on Tuskegee University, the campus. And so you have a National Center for Bioethics and Research and Health. This is an extremely old building. It was originally built in 1892 and renovated in 1999, but this renovation was mainly to add on a part to the building and not to completely renovate the building itself. It's an extremely old building. My mother was born in that building. So, and so what Tompkins Hall was built in 1906, still pretty old, and it is used as a current day cafeteria. That's why it's very important for us to test the water there. And then we have Mars and Mayberry Hall, which was built in 1950s. This building is mainly used as a faculty building. So now we have the locations at the city lake. And so site number 1 was at the overflow drain. Site number 2 was near a bunch of trash near the residential areas. Site number 3 was actually at a fishing dock. Site number 4 was at a pavilion where there was a trash can in the water, which you will see. And site number 5 was in a greenery area where people don't really go to because there's so much overgrown vegetation. And so here are just some of the locations. As you can see, there's lots and lots of trash in this recreational lake, and you can see the trash can just floating. And so with the GPS photo of the equine pond, you can see there's a lot of greenery around the pond. And so we took from One location, which was in the sun with a lot of greenery. Second location was in the part between the greenery. And the third location was actually closer to the farm area, as you can see right here. Downhill from it, it was a bunch of greenery. As you can see, you have tons of greenery here, tons and tons of greenery here, and then there's this weird gap spot. And so I analyzed all these different physical, chemical, and microbial properties. Of course, we're not going to get to all of them. So I analyzed the ammonium nitrate, the calcium hardness, and total hardness. We'll get to these on this side. And so for the pH treatment, the closer they are to 7, the lower the impurities in the water are. The further away from 7, like we have some at 5.7, the higher impurities in the water. And so the Tuskegee University water is the closest to 7, along with other treated locations, while the city lake is the furthest from 7, except for this one spot we'll get to. And so the nitrate and the phosphorus properties, Kinney Hall has the highest, and this is due to corrosion prevention. Phosphorus is usually used in pipes to prevent corrosion from further. And as you saw, it's an extremely old building, so corrosion will happen. And so for the higher nitrate, it's from agricultural runoff. This is from the equine pond, location 3, which I said was down the hill from the farmland, and all that runoff is going into the pond. And so now these are the overall chemical treatment for the Tuskegee University treated locations, and I'm just only going to point out one chemical per graph. So it had a higher calcium hardness, which causes corrosion, and this is also at Kinney Hall, where the corrosion prevention is also occurring. On this chart, something that stood out was the higher chloride parts per million. And this is an indication of external contamination that is seeping into the pipes that is causing the chloride to react to those contaminants. And so the next graph, which is Tuskegee University's untreated location, otherwise known as the equine pond, you have a higher free carbon dioxide content, which this is to be expected when you have high amounts of greenery. A lot of that greenery tends to die. And so it's just an indication of that decaying matter in the water. And so this is the city lake, and it has a higher alkalinity, which this location, again, this is location 1, which I pointed out earlier, that has a 6.1 pH, which is highest pH in the whole lake. That's terrible. And so it's just a pH resistance to change from where it's already at. And so the detected copper was detected in all untreated locations. However, it was detected in one treated location, which was the city tap water, location 2. This is due to corrosion in the pipes. A lot of the buildings in this town are pretty old. So the pipes tend to corrode, and this was one of the instances where that corrosion got all the way to the spigot. And some striking results are that cyanide was actually detected at the fishing dock. It was less than 0.5 parts per million. Further testing needs to be done in that specific area to make sure it's not at a level where it can physically harm people's skin when they do go fishing, because fishing is a recreational activity that is done a lot in that town. And with the chloroform bacterium, it was detected in all outdoor locations, which is to be expected because it occurs regularly outdoors, but it was detected in none of the treated locations. And so for the conclusion, treated water sources did show lower chemical and microbial contamination, which that was to be expected. Untreated water bodies did not display a greater variation in the chemical and biological parameters, which was a surprise to me. A lot of the water was very similar in the places that I tested. All water sources treated and untreated did not show any severe level of contamination. And so here are my social recommendations to keep you clean. And so tap water, this is mainly in public locations where you're using public restrooms. Public restrooms, as y'all may know, if y'all have used one, do not have a lid to the toilet. All that fecal debris is spraying out of the toilet onto the spigot. You need to run it for at least 30 seconds to make sure none of that debris gets on your hands, because I would hate to have someone else's fecal matter on my hands. For the pond water, I would not recommend swimming in, only because of the high nitrate concentration. But from the parameters that I did test for, it would be safe to eat the food from there. Of course, you cannot eat it from the Tuskegee Equine Pond because that's a private location. But with similar conditions that this one had, I would recommend. The city water, city lake water, I don't recommend swimming in. I do not recommend fishing in. that water looked nasty. Just the pH alone would have let me look the other way, you know what I mean? And so here are my references. Here are my acknowledgments. And do I have any questions, comments, or concerns? Okay.
Really good presentation. And I love the social implications at the end because that's the piece that we all need to hear. So very nice job with that. One of my questions is, you said none of your levels were found to be severe. However, you don't recommend getting in the Tuskegee Lake. So is that just a personal thing, or is there some kind of level there that is considered harmful?
Okay. So when it comes to outdoor water sources that are not treated like pools, it is more difficult to detect contaminants unless someone actually goes out there to detect those contaminants. And so I personally, and in some levels scientifically, would not swim in water that has a pH below 6, only because of those contaminants being so severe and so acidic that it literally switches the entire acidity of a lake. And you saw how big that lake was. Yeah. And for it to be able to switch an entire acidity of a lake, it has to be in such concentration. And I only tested for those contaminants. There are more contaminants that I personally did not test for that could be present that is making it more acidic.
Absolutely. That's a great answer. Thank you. My second question is regarding the cyanide. Where do you think that was sourced from?
Okay. So Tuskegee is a semi-rural town, and people typically have little gardens in front of their yards, and they'll treat those with fertilizer. Some fertilizer hold cyanide components, which wash into the lake when it rains. And you also have the mismanagement of trash. As you saw, there was a whole trash can in the water. So if someone were to throw their pharmaceutical waste, because it is difficult to find a place to dispose of your pharmaceutical waste in a rural area, into a trash can, and the trash can gets drifted away by wind, it'll land in the water, causing it to react to it, causing all this acidity, and could have cyanide in the water.
Got it. Thank you so much. Very good job.
Thank you.
Thank you so much. Just a random question and thought maybe. pH is correlated to temperature. And my question is, did you measure all of your various physicochemical parameters at the same time of day? Or did you do this multiple times, and is there a change over time? Thanks.
Okay. That was one of my limitations. I could not take multiple samples like each week at the exact same time to get a baseline of what it usually is. But everything I did take was at the same time of day. So when I went out to the lake, all those samples were taken at the exact same time of day, when I went out to the equine pond, all those samples were taken at the exact same time of day. It wasn't like, oh, I took this, I'm gonna wait for 30 minutes and I go out and take this and I wait for 30. No, I was taking them at each location at the exact same time of day.
Cool, thanks. Maybe a follow-up. Do you think that your study should become a longer term thing? Should we monitor these stations because it's
Yes.
so important?
Absolutely, because a lot of problems with semi-rural and rural areas is that they don't have those kind of monitoring capabilities. And a lot of times, water, it's all connected. So once you have contaminants in the city lake, seeps into the ground, it goes through an overflow drain, which is present. It can go all the way to the Mississippi River and can go all the way to the Gulf. So everything is connected. And so a lot of times when we only look at bigger water bodies, we kind of miss the little water bodies that do affect small communities. So yeah.
Yeah, thank you so much.
Hi, Jacqueline. Not a question, but I just, first of all, want to say congratulations to all of you that presented here today. And I'm not singling you out, Jackie, because I also know at each of the different stations, you guys did more than what you presented. Even though we hear just one story of experiment or project that you did, while you were there were other projects and experiments you were involved in, which speaks to some of the things that we also as faculty will always do while we are running some other things. We are also having our hands in other different projects. And that's part of the training. And for Jackie, while she was doing this, even though she's reporting one experiment, she has other 2 experiments that was also going on at the same time, doing some experiment on soil microbial community, doing experiment on soil enzymes. And she took, out of the 10 weeks, she took 2 weeks off to actually organize ROV competition for some high school students, where she worked with over 20 students along with Dr. Alston. And I'm surprised she didn't put those pictures up there, but just again
my
to
personal bio, y'all read it.
Yeah.
Everything I've done scientifically.
Yeah, so I just want to commend all of you and say, yes, this is what science is all about. It's not just focusing on one thing. You can be more than one thing at the same time. And being able to handle all of that really speaks to your ability and should give you confidence to know that, yes, you can do anything. Living here today, you are able to actually do this, even if you choose to be a scientist. It's not something beyond your ability. So I just want you guys to know that, and I want to congratulate all of you. Thank you.
Great job, Jackie. You had a lot of encouraging messages online. I'll just read a couple of the highlights. From Tosana Lewis, we have, "Go Jackie, we're so proud of you. Keep diving into your brilliance, and we are cheering you on from the surface." And then we also have from Nancy Wallace, "Congratulations on such an engaging presentation. We are so proud of your work."